Are we recording? Yes, we're recording. So version 5.6 is the as yet unreleased version. So version 5.5 we talked about last time, and it has since been released. This is not really part of the formal plan that I'd put out for moving to kind of Webpack and splitting up the core into lots of different plugins and flattening the structure. This is a kind of set of features that are have been missing from Adapt, and a rewrite of a few pieces, because we're now at a stage where we can tackle some of the outstanding kind of technical debt from Adapt's history. So this issue has a document on it which goes through the rationale for 5.6 and kind of goes through the problems and the solutions and prototypes. Hi, Dan. And these, all of these solutions have got pull requests for them. So you can see listed on the original ticket are the outstanding pull requests that need reviewing before we can release 5.6. The first bit is the problem. So at the minute, Trickle is really complicated. So this is the current version of Trickle, and it's all, the whole thing's pretty much based around trying to truncate the page. In the original version of Trickle, what basically happened is that all of the blocks were rendered, even the stuff that's off the page. And then the Trickle extension had to truncate that page, so it had to set the height manually to the bottom. We kind of had no option but to do that, because when a content object or a page renders, it renders all of its articles first, then those articles render their blocks, and then the blocks render their components. So it kind of renders in columns of type. But what that really means in practice is that the parent is always rendered first, and then the subsequent children are rendered. And this is a bit of a problem with extensions like Trickle, where we need to stop the rendering after a set of components has come out. So in this case, we would have wanted to stop the render after B65. But we couldn't, because Adapt will just render everything. So Trickle at the moment is based around pages and around truncating the page, which is a mess. And so the first part of this, the first problem that we got is Trickle, and the solution to it is this child views API. So that's the one I'm going to cover first. This is the PR for it. It's quite a heavy pull request, but essentially what it does is it rewrites the add children function on the basic view. So in Adapt view as it is, so this is the view that is extended for articles, blocks, pages, components, menus. This is just kind of the set of standard behavior. And add children, you can see here, basically goes through and gets all of the children for this particular view. So if this was the page, it would be going and fetching all the articles, it would be looking up the article, and then it would be putting it into the document object model. And so this is kind of that parent first style that I was talking about, where each of the views that has to be rendered will render its immediate children and then forwards. Now this change that I've got, the add children, what this does is it switches the add children, it basically extends the add children and it renders child first. So what will happen is the page will render, the first article will render, the first block will render, and the first component in that will render. And then the second child will render, and when it runs out of children, it will go back and it will render the next block and the next set of children. The extension to add children here also allows us to stop the execution of add children, so we can halt the rendering process at any point, anywhere we like, and then when we call add children again, it will carry on from where it left off. So with the old version of add children, if you were to call this twice, it would add all of the children twice. Whereas with the new version, what will happen is that it will just pick up from where it left off. So it is almost what you would consider to be a breaking change to the add children function, but for all intents and purposes, it just does exactly what it did before, because we never called it twice. So it will now go through and it will get the child models, but it gives you some opportunity to stop this rendering process. So it changes adapt quite substantially just by changing one function. Now what happens with add children is every time it wants to add a child, it will trigger a global event saying, I'm just about to add a child, has anyone got any objections? And likewise, when it gets to the end of the list, if it's allowed to, if this particular property is set, it will say, I've got to the end of my list. Does anybody want to add any more children? So we now have two mechanisms by which to stop the adding of children and inject new children, which really helps with trickle, because trickle can now just stop when it should stop. It just locks the page. So if we have a look at it in practice, go to an assessment page. This is using a new version of trickle, and as you can see, it has only rendered one block, whereas the contrast from before was where it had rendered all blocks. So trickle, so this prototype has a rewrite of trickle in it, which is vastly simplified. And all trickle does is say, these are all the places that I want a trickle button, and it puts a component in for the trickle button. And then it says these are all the places that should be trickle locked. So everything forward from the button that it's just injected on the page will be trickle locked. And trickle, once it's unlocked, will then call add children again, and it will continue the rendering process. So if we complete this, what you'll see now is that the button's appeared as it was injected at the bottom of the block. So this is basically just a trickle component that's been injected outside of the block inner. And when we click go, it'll render the next block, and so on and so forth. So you can see the next trickle button is already in place. What are we? Block extension and component. And so that button will show, and so on and so forth. And it will just go down like that. So that's the first part of the document. Essentially, is that we really needed to rewrite trickle because it's a mess. So the newer version of trickle looks something like this. It's a main controller, and it's a component. So it's the normal trickle button kind of register view and model, and then there's a view for the trickle button and a model for the trickle button in the same way that an accordion or a GMCQ would be made. You can see here that it's add trickle components, does what I described before. It injects all of the components into the models where they need to be, creating components as it goes. And then there's also setup locking, which will go through all of the subsequent models and lock them until trickle then unlocks them. Now the beauty of this is that all of the locked models now have the isLock property set to true or false accordingly. So all of the other extensions in the course can now see which components are locked and which components aren't locked. which necessitates a change to page level progress so that it can grey out all of the things that aren't available. So you can see here, this is using the isLocked property rather than the original version where it was using the isVisible property. But we end up with a much easier trickle extension to understand. And we also end up with the add children mechanism, which helps us a bit later on when I get to branching. So that's trickle. Branching is something that people have been asking for in Adapt for ages. And branching has almost exactly the same requirements as trickle. We need to render a question on the screen, and depending on that answer, we need to render another question underneath it all the way through until we get to the end of the branch. Now, branching has some quite complicated use cases. So if we were going to add looping into branching, so you could come back to a previous question, the trouble that we've got is that you need to render the same question twice. So if you were to go through a branching scenario, so if we let's say this question components page where we've got MCQ, GMCQ, text input matching slider. I'm sure a lot of us know the answer to those questions, but what I've done is set that page up as a branching scenario. And the answer to these questions will determine what the next question is out of that original set. And there is some looping in it. So what you'll see here is that the answer is 1917. If I answer it correctly, it will go to the GMCQ. Partially, we'll go to the text input, and incorrectly, we'll jump to the slider. So if I do incorrectly to start with, what we're going to end up with is the slider, which was the component at the bottom of the page. So we've already reached the end of the branching scenario. So answer 5 to 9 to finish, and then we get to the end. If I were to answer that slightly differently, so let's answer it correctly to go straight on to the GMCQ, which was the next one in the row. So 1917. The next component is the GMCQ. So this is using the add children extension now, and it's injecting components rather than just stopping. So it's stopping first and foremost at the branching, and then it's injecting the next component based upon the answer to the question in the previous. And the configuration for it is really simple. It looks like this. So you can kind of see all of the branching blocks just do exactly as you would imagine they do, but this simplicity allows us to loop blocks. So in here, if I now answer this incorrectly, I can go back to the MCQ. So if we do 3, because the correct answer is 2, the MCQ will appear again. It's the same MCQ that we had on the top. So the child views API allows us to inject components to render, which is quite easy. But now we're rendering 2 components from the original set. So in the configuration for this, we only had one of each. We don't have 2 copies of the MCQ. So you can kind of see that this section here starts the branching scenario. So this is the MCQ, the graphic that goes next to it, the GMCQ, the text component, the graphic component, the matching, and the slider. And then the completed block at the end. So here what's happening is that we're cloning the original model, the original MCQ. So what the branching extension is doing is every time you want to render a model, it's cloning the original and injecting it into the parent, And then as adapt comes to render that view, it's rendering the clone and it's not rendering the original. So here we've just got multiple clones of the GMCQ. So if I or the MCQ. So if I answer this incorrectly again, we'll get the MCQ again, and then we'll get the GMCQ again. And of course that necessitates a whole new API in adapt. So if we didn't have the looping, this would be quite easy, because we would just have that series of components that were rendered, and we would just draw them one by one by one by one, missing out the ones that weren't in the branching scenario. But because we've got looping, and because that's a really fundamental requirement for most branching exercises, I've kind of incorporated it into the first version. So this API is the deep clone API. So that's also part of the original documents of the deep clone. There's a description of what it does in the document and also on the ticket. What it does is it clones the model and all of its children. So in this case, if I clone a block, it will clone the block and its components. If I clone an article, it will clone the article and its components. It will inject that clone into the original parent ID append it to the end of the bottom of the original parent ID. So if I clone a block, then it will get appended to its article unless I tell it to append it somewhere else. And it gives you options to modify each model as it gets cloned, and to set properties on the primary cloned object, and to set properties on all of the cloned objects. It's quite a simple bit of code. It's not quite as complicated as the child views. The bulk of it's here. It's just one function. So deep clone lets you set properties on the thing you're cloning, set on the children, and provide a function to modify each as it goes. This has kind of necessitated a cleanup of the toJSON function, which a PR that's already gone through, because this was coming through with nested models in it. But that's all it does. So branching uses the deep clone and the child API to essentially give us a branching scenario, which is all fun and dandy. So let me answer this correctly so that we can get to the end. So there we have it. And then when you come back in, you can see that all of the branching scenario is as it was. So this then leads to the problem about what to do about saving branches, because there's a load of models there that weren't in the original JSON because they're clones, so duplicates. And so you'll see I'm using the SCORM test harness. So if I refresh this page now, the branching should still be there, and it should be in exactly the same order that it was, except for a few minor. Oh no, I might have answered those incorrectly. Yeah, I did. So you can see it's restored it exactly as it was when I left. So we now have the possibility of branching with restoration as well. And this branching extension doesn't just have to be on blocks, it could also be on articles. It's kind of structure agnostic. So that saving and restoring required a different set of PRs. So we had an extension to offline storage, so you can now basically use the mechanism that offline storage had in it, or Spore had in it before, for turning the user answer object into something that can be saved in SCORM and something that can be pulled back out as suspend data. So there's 2 or 3 extra functions. There's a force Spore to save, and there is a serialize and deserialize, which lets us save more complicated stuff in Spore. You can kind of see that here. So in Adapt Original, we've got really horrible objects like this. This is the assessment saving its state. And you can imagine in the authoring tool, all of these IDs are going to be really long. So it would be quite easy if we had 2 or 3 assessments in here with 20 questions each to completely exhaust the suspend data. So as part of this adding these new APIs, I've also rewritten the serializer, which kind of reduces the amount of data that's required, and done a series of PRs to get the assessment to utilize those new APIs. So in the later version, the version 5.6, you can see that the assessment is now, I haven't actually saved an assessment yet. Branching questions, let's go and do a bit of an assessment. So now I'm just going to go through and have a go at the assessment so that we can see what that looks like. So in here you can see that this is the assessment now. I've reduced the names from full assessment. This describes the article that it belongs to, and this describes that what was otherwise a very long-winded notation of characters. It's now compressed into a much smaller space. So that allows that in combination with branching allows us to not only not exhaust the suspend data with branching, but also include quite a few branching scenarios and assessments more in our courses, simply because it can store much more data in a smaller place. So that's the suspend data rewrite. The next PR, the next part of this, is how we save and restore the branching. Now with ADAPT, normally when you answer a question in ADAPT, so let's say if I answer whatever this is, the GMCQ, C65. What we'll see in here is that the user answers have been saved. So this is true, false, false, which describes the options. So option 1 has been selected, true, and the other 2 have not been selected. And it says whether it's correct or not, and how many attempts, and the general state of the component as it is now is saved. Now, in the branching scenario, we've got multiple questions, multiple instances of the same question being saved. And so the normal storage mechanism doesn't provide us any way of doing that. And so this new API, which is question model attempt states, is a way of storing the history of every answer to the question, every user answer to every question in the course. So if I were to, for example, go and get, so this component, this is a clone, so you can see its ID has got an extra unique identifier in the front of it. But the original question was C250. So this was answered 1, 2, 3, 4 times in the branching scenario. So C250. So if I were to go and do the same thing for C250. What we now have is a series of new functions that come along with this API. So we've got get attempt object, set attempt object, add attempt object, and get attempt objects. And what get attempt objects does is it returns all of the states of that component after it was last submitted. So here you can see the first attempt we've got up here, which was answered correctly. The second attempt was also answered correctly, and the third attempt was probably also answered correctly, and so on and so forth and forth. So the attempts API is basically just storing the state of the question every time you answer it. And that works obviously across sessions. So if I refresh this and the same thing again, see that the temp stage object are restored as we go through. So this obviously creates a much larger data problem, which is already solved by the changes to Spore with the rewrite of the serializer. So we can store loads of these. So the branching extension, what it does is it uses a combination of the child view API to stop adapt rendering. It uses the deep clone API to clone a series of components as it goes through, and then it uses the attempts states to keep hold of every answer to this question, to the original question as it goes through. So the original question is actually having a history added to it of the times that it was answered as a clone. What happens when branching then comes back round as it restores the original MCQ, it knows that it's had 5 attempts. And branching has also stored the order in which the questions were asked. So it's stored the tracking ID for each one of these blocks. So it knows that it's got to restore this tracking ID once. So it goes and finds the first attempt from the original question and restores that value. It's then knows that it has to do a GMCQ. So it's the first attempt on the GMCQ. It will go and find the first attempt on the GMCQ. Then this is the second attempt on the multiple choice. So it will go and get the second attempt from the original GMCQ and so on and so forth. The branching extension is quite simple. It's using a series of new, quite abstract APIs, but it uses them together with the effect of being able to save and restore a really complicated looping branch scenario. So are there any questions so far? That's quite a lot to take in.
Yeah. Can I just ask, Ollie, is it just the index of the array is the identifier in terms of the order of those? There's nothing further within that object?
The get attempts object, this is the index basically just describes the order in which
the order.
So that's the last answer and that's the first answer to it.
Yep. That's fine.
The branching extension stores the tracking IDs in order, so it would store the tracking ID for whatever this is. Say it's number 1 for the MCQ, so it would be 1, then 2, then 1, then 2, then 1, then 2. And all it does then is figure out how many times it's had to restore a 1 and goes and picks up the correct item from the get attempts object. So branching is this kind of amalgam of kind of assumptions and new APIs that all come together. And so the attempts state stuff is also quite simple. I think it's in the question model. So it's just a series of new functions at the bottom of the question model. Get attempt state, this returns a state object that is easy for the Spore serializer to handle. So it's just an array of numbers, booleans, and arrays that can have nested arrays of numbers and booleans. So Spore can only save numbers, booleans, and arrays using its serializer. It can't save strings or anything more complicated. And it has to store an array of the same type of value. So this is why I've divided it up into an array of numbers, an array of booleans, an array of arrays. So each model now has, you can get the state of that model. So if I were to go and let's see about this one here. So if I answer, what is that? That's C60. So if I were to get the attempt state of C60, it would return to you an array, a rather meaningless looking array of values. But you can get the equivalent by getting the attempt object, which is the JSON kind of readable version of exactly the same thing. And this describes the current state of that MCQ. So as it was answered. Now if I show you what it's like before we answer it. So this is what the attempt object looks like before I've completed it. It's just rather empty. It's not complete. It's not correct. It doesn't have any user answers in it. And then as soon as I've answered it, I have a different state. Right? But I've also got a history of the states. So this, with the plural on the end, it actually gets a list of all of the different states that were answered. This is quite fun when you use it with is reset and revisit. So I could keep resetting this question, and it would keep adding attempts history to it. It will even work with the reset button. So if you were to actually add multiple attempts to this question, every time you do a reset on it, it will, and then as following submit, it'll add an attempt in. So we could have all kinds of new extensions. Well, you've tried this 6 times and you've got it 30% correct. That's all now kind of possible just from using the internal adapt APIs.
On a semi-related note, if you're using branching inside an assessment and you do have some, and you've got the deep clone working as well, so you've got some questions which are cloned and repeated, how's the overall score calculated for that assessment?
So well, I'll get onto this in a little while, but the current assessment and branching won't work together in a minute.
Right.
So I'll cover that in a second.
I was thinking it'd be a pretty mental thing to want to do, to have branching inside the assessment anyway.
Yes, it would indeed be a mental thing to do. We'll get onto infinite scroll before we tackle the assessment, because that's what this bit's about. So infinite scroll is one of those use cases.
Ollie?
Yep.
Before you run on to infinite scroll, has styling of these cloned objects been considered yet? I understand that with when an object is cloned, we are prepending part of the ID, but just wondering if there's any way that we can style a branch differently than the original.
There's no reason why you can't. I mean, it's a prototype extension at the moment. So when when all of these PRs are in, I will move the prototype over to the adapt repo, and then we can actually look at how we go about styling them. It might just be a simple case of keeping the same ID in the classes section for the particular component, but I haven't really considered styling at the minute because I'm just doing.
Yes, that's understandable. Just was curious.
Yeah.
All right.
Yeah, there's no reason why we couldn't just keep the original C250 and. But
well, I'm sure that we can get this. I would expect that we'd be able to get it worked out, but we want to be able to have some type of class or identifier that's different from the original, wouldn't we?
Yeah, well, in the branching scenarios, the original never gets shown. So what happens when the branching extension starts up initially is that it goes, oh, this article is, or this article is configured as a branching article. And it hides all of the children, so they all become is available false. So you never see the originals, you only ever see the clones. So yeah, we are going to want some way of styling them, whether it's the number of times as well as
Right.
the original ID and all of that stuff. I haven't really considered styling.
Yeah, that's understandable. Okay, thanks.
So that's basically trickle with branching. So you can see that branching and trickle here are all playing with the child view API in order to control the page in the render. And every time you click continue, a new block will get added based upon the answer you have to that question. So moving on to infinite scroll. So infinite scroll is one of those strange requests that we get asked for every now and again, but that's not really important to adapt. I've just included it here as an example of a rendering control mechanism. So infinite scroll is nice if you've got 100 components on the page and you don't want to have to wait for them all to render. You only want to render what is immediately scrollable to the user. And so I've got an infinite scroll extension in here. Now you can see that the scroll bar here is quite short. And in the original course, the scroll bar is quite a bit longer. So presentation components goes from the text all the way down to the accordion. What's happening here is the infinite scroll has truncated this page so that only the first few elements that are needed are rendered. So in this case, the first 3 blocks. I think it's a full screen length plus another screen or half a screen. Can't quite remember. So as you scroll down, what will happen is that it will render more blocks as it deems required. So you can see them rendering as I scroll, and you can see the scroll bar changing height. Now this is using the child view API to stop the render at an arbitrary height mark. So it doesn't have to be used for trickle or branching, where the use case for content display is the reason why you're stopping the render. In this case, it's just so that we can spread the loading of kind of resources. So infinite scroll is very handy when you've got a lot of resources that you need to load and you want to distribute them over time over a connection. So the user is expected to read this stuff, and as they scroll down, they'll get new content. Now, what you'll probably appreciate is that that has quite large implications for things like the PLP. So if I were to jump to accordion isn't on the screen at the moment. It's not been rendered. And so along with the child view API, there's also a series of APIs for forcing the render of up until a certain point in the page, or just forcing components to render full stop. You can do that even if trickle is interjected or if branching is interjected. You can just tell it to carry on forwards. So this is what PLP is just about to do. It's you'll see the scroll bar jump up as it renders all of the components, and then you'll see it scroll to them, and you'll see them get rendered in here. So I go straight to the accordion. It jumps right down, and the same would happen if, for example, I was going to go to v5.7.0 by ID. It would, I'm not sure if you could make that out on the screen share, but it does exactly the same thing. It will jump to the page, it'll render out all of the components that it needs to, and then it will scroll to them. So the child view API comes along with a series of tools that allow you to force the render or not force the render. So where are we? Release candidates, views, component object. So in here you've got the render to function on each component object, which just does what it says on the tin. It renders up to the ID specified, and it uses the new add children event. So it's running this function here, and you can see that it's forcing the child to render as it goes until it gets to the bottom. And all of these APIs are promises now. So add children is a promise. If you call add children, it will only call back if you wait for it once all of the children have been, all of the children that it can up unless something interjects are in the process of being rendered. And when ready here is just basically says when all of those views are ready. So when I've added all of the children that I wanted, when they're ready, then continue. And so PLP now uses the render to function to jump to the ID that it wants. It renders up to the point that you've asked it to, and then it waits for those views to be ready, and then it will go back to doing its original behavior. What else did I have? No, I think that's about it. Oh yeah, banking and randomization. So we've done attempt states, we've done deep clone, we've done child views. That one obviously will need a a proper read if you really want to see how it works. Offline storage API is about rewriting the serializer and adding the new functions to extend it. So banking and randomization is the last problem on this list. And these two things you can only do in an assessment article at the moment. So those two requirements or use cases belong to the assessment. And so if you wanted to do a series of banked blocks, or you wanted to randomize the blocks, at the moment you can't do that unless you use an assessment. And so my proposal in here is to, at some point in the future after 5.6 has come out, to remove banking and randomization from the assessment. Banking is, of course, where you have a series of blocks that are grouped together into some topics, and then you pick a set number of items from each of those topics, and you display those things instead of the original set. So in the same way that branching has an original set of blocks, except branching clones the blocks as you need them, banking would have an original set of blocks and it would pull out a subset and render those instead. And randomization would either pull out a subset and randomize them, or just randomize the original ones that were in there. And those can be two separate extensions. They don't need to be part of the assessment. What that then allows us to do is make the assessment much more abstract. So the assessment can be all of the questions on a page, or all of the questions in an article, or all of the questions in a block. And you could put branching, banking, or randomization inside an assessment without having the assessment have to understand that it's doing banking and randomization or branching in there. The score, Pete, as you described, would be just the maximum score of all of the questions that were covered by that more abstract assessment versus the actual score that you got from those individual questions. So if you had 15 questions come out of banking, then that would be your max score, and your score would be whatever you got as a result of answering those questions.
Cool. Taking into account the final attempt on anyone that you've done multiple times, or the best attempt, or a config option.
Yeah. Either way, but I mean that's up for us, isn't it?
Yeah.
Obviously, the banking, it just takes the number of questions and the number that you got correct. Branching could be the same, just the number of questions and the number you got correct. It doesn't have to be based upon the last correct answer for a particular question, although it could be. But we'll see. We'll work that out in the future. So we have with v5.6, we have a rewrite of trickle. So trickle becomes a much simpler thing from as it was in the current version of Adapt. Where are we? So trickle goes from all of these files down to just 4. We have the infinite scroll extension, which will probably never get used in production, but you can kind of see how it works. It listens to any time a view is trying to add children, and it goes through and it basically figures out, it's the window height times 1.5. And then it just stops. It stops the view from adding children when it either hasn't got the view that it's expected to have, or when it has got over its rendering threshold. So it's quite a simple extension. And then you can see once you scroll again, it goes back to finding the parent view on the page and adding the children. So that will then cascade all the way through the children again, go through the same process of asking whether it should add children, and infinite scroll will stop again. Trickle does almost exactly the same thing. So it has an add children function, and if the model is trickle locked, it will stop the add children from rendering. Branching is pretty much the same thing, except this is for requesting children. So on request children here, picks out the next model in the branching and adds it in, and stops afterwards. So you can either stop before this child is rendered or stop after the child is rendered, and that's kind of what the true or false is, but there are a series of other options in there. So you can either force stop now, stop next, reset, that kind of thing. So the event object that comes through from the child view API is a kind of consensus object where all of the extensions figure out a consensus on whether they're going to stop or not, which is then overridden by the render to on the parent if it needs to. So that's branching, infinite scroll, rewrite of trickle. There's obviously some changes to page level progress because it has to overcome the fact that it stopped rendering. Assessment has had some modifications so that the stuff that it saves to offline storage is much shorter than it used to be. Spores had a lot of work, as you can kind of see from the output. It's much more concise than it used to be. So B is for branching, C is for components or completion. Q is for question state, so this includes all of the traditional save states plus all of the attempt histories. And then A was for assessment at the end. And these things are all kind of reverse engineerable. New API. So adapt offline storage.dc. I'll give you the original. So this is basically the block completion as we used to have it. So a false is the block's not complete, and a true is the block's complete, and the tracking ID. So I've added a new kind of info log to get the old block statuses as they were. Basically, because I've compressed the zeros and ones, we now have to have an info line that spits out the zeros and ones as people are used to, because that is now compressed into this. So the suspend data is much reduced, but we get the same benefit of seeing the block tracking IDs, the block completions. So are there any questions? I know this has been quite a big one. Can you all still hear me?
Yeah.
Can indeed.
Yeah. No question.
So, yeah, I know a stunned silence and clearly lots of appreciation. I have a question. So we've obviously got lots of PRs for it, and it's in the prototype state. How much more work needs to go into it before it will be released as a full ADAPT framework release?
Attempt states has been thoroughly reviewed by Tom and is pretty much ready to go. It just needs some more +1s. Deep clone, as I said, is a really simple. It's got one more +1 needed on it. The child views API, I'm not sure that's got any +1s. Oh no, it does. Just one. Okay, here. But this is the one this is the largest one that's going to need. It's going to need scrutiny. It's not complicated. It's a loop with some events that fire off, and the result of those events basically continues or stops the loop in its simplest description. And the offline storage stuff, Matt and Kaya and Tom have been reviewing, and it's very nearly close to being accepted. I think just one more on there. So not far off is the answer. And once those APIs are in, I can move the branching. So all of these prototypes, so the infinite scroll I'm not sure whether this will go into the adapt repo, probably not. But that's all there. It's all available for people to read. The rewrite of Trickle is here. I haven't done the accessibility stuff or the button auto hide yet, but they should be really easy to put back in. And everything else I think in here is working fine. Yeah, I just have to test out. So collectively, we've just got to test out that all of the use cases for Trickle that we would normally use still work. And then the branching one will definitely, so the Trickle will go into the core, overwriting the Trickle as it is at the minute. And branching is we can move over whenever, and people can scrutinize it. And as Chuck was saying, we need some styling mechanisms, and I'm sure there'll be some bugs in here. But yeah, I mean, quite quickly is the answer.
Fantastic. That's what I like to hear.
Yeah.
Cool, lovely. Well, thank you very much, Ollie. Does anyone have a final burning question that they'd like to ask while we're all online?
No, thank you.
Yeah, no thanks.
Cool, superb. Well, thanks to everyone for joining, and thank you very much for Ollie for presenting. And I will get this uploaded to YouTube and up on the forums as soon as possible. So next week at some point.
Brilliant.
Thanks for your work,
Thanks very
Ollie.
much, guys. Yeah, great work.
Thanks, Ollie.
That's
Great.
Cool. Take care. Have a nice weekend.
You too.